National Electrical Code Article 110(23)b states that motors and equipment shall be tested to frequency and voltage that will not damage the equipment. Article 110(25) requires electrical equipment to be tested to ensure its safe operation. Article 432 states that testing is not required unless specified by the manufacturer. Article 604 states that testing is not required unless specified by the manufacturer. Article 703 requires standby power systems to be periodically tested to ensure their proper operation. It is important to note that OSHA electrical standards, specifically 29 CFR 1910 subpart S, requires electrical equipment to be tested and maintained to ensure safe operation. Manufacturers' instructions may specify specific testing requirements for their products. Local codes and ordinances may have additional requirements. There is no specific section in the National Electrical Code that outlines requirements for an electrical testing shop specifically for three-phase motors and equipment. However, the general requirements and considerations previously listed apply to three-phase equipment as well. Here are some additional recommendations. Firstly, use a licensed electrician to perform testing. Secondly, ensure that the testing equipment is calibrated and maintained regularly. Thirdly, test equipment under load conditions to accurately assess its performance. Fourthly, document all testing results for future reference. When testing electrical equipment, especially three-phase motors and related equipment, it's essential to understand the relevant regulations, safety standards, and best practices. While the National Electrical Code doesn't have a dedicated section for three-phase motor testing shops, several articles and external standards provide guidance. Article 110, which covers general requirements, provides fundamental principles. Section 110(23)b emphasizes that testing should be performed at frequencies and voltages that won't damage the equipment under test. This highlights the importance of using appropriate testing methods and equipment to avoid causing harm to the motor or other electrical components. Section 110(25) mandates testing electrical equipment to ensure safe operation. This overarching principle underscores the need for thorough testing procedures to identify potential hazards and ensure the equipment functions as intended without posing risks to personnel or property. Article 430, dedicated to motors, includes Section 432, which clarifies that testing isn't mandatory unless the manufacturer specifies it. This means that unless the motor manufacturer explicitly requires testing, it's generally not a mandatory requirement under the NEC. However, it's always a good practice to perform testing for safety and performance verification. Article 600 addresses electric signs and outline lighting, with Section 604 echoing the sentiment that testing isn't required unless the manufacturer specifies it. Again, while not always mandatory, testing is still recommended for ensuring safe and reliable operation of these types of equipment. Article 700 covers emergency systems, and Section 703 mandates periodic testing of standby power systems to ensure their proper operation. This is crucial for ensuring that emergency systems function reliably during power outages or other critical situations. In addition to the NEC, several other considerations come into play. OSHA electrical standards, specifically 29 CFR 1910 subpart S, require electrical equipment to be tested and maintained to ensure safe operation. Compliance with OSHA standards is essential for workplace safety and regulatory compliance. Manufacturers' instructions often specify testing requirements for their products. Adhering to these instructions is crucial for ensuring proper operation and avoiding voiding warranties. Local codes and ordinances may impose additional requirements beyond those outlined in the NEC or OSHA standards. It's important to consult with local authorities to ensure compliance with all applicable regulations. Since there isn't a specific section in the NEC that outlines requirements for electrical testing shops dedicated to three-phase motors and equipment, the general requirements and considerations mentioned have applied to three-phase equipment as well. This means that the same principles of safe testing practices, adherence to manufacturer instructions, and compliance with relevant codes and standards still apply. In addition to the regulatory and code-related aspects, there are several practical recommendations for operating an electrical testing shop for three-phase motors and equipment. Firstly, using a licensed electrician to perform testing is crucial. Licensed electricians possess the necessary training, experience, and expertise to conduct tests safely and accurately. Secondly, ensuring that testing equipment is calibrated and maintained regularly is essential for accurate and reliable results. Calibration ensures that the equipment provides accurate measurements, while regular maintenance prevents malfunctions and ensures optimal performance. Thirdly, testing equipment under load conditions provides a more realistic assessment of its performance. Simulating real-world operating conditions can reveal potential issues that may not be apparent during no-load testing. Fourthly, documenting all testing results for future reference is important for tracking performance trends, identifying potential problems, and demonstrating compliance with regulations. Detailed records can also be valuable for troubleshooting and maintenance purposes. Here's a more detailed breakdown of key testing procedures and considerations. Insulation resistance testing measures the resistance of the insulation surrounding the motor windings. A low insulation resistance indicates insulation degradation, which can lead to short circuits and motor failure. Megometers, also known as insulation testers, are used to perform this test. The test voltage should be appropriate for the motor's voltage rating. Winding resistance testing measures the resistance of each motor winding. Variations in winding resistance can indicate shorted or open windings, which can lead to unbalanced currents and motor overheating. Ohmmeters or micro-ohmmeters are used to perform this test. The measured resistance values should be compared to the manufacturer's specifications. Surge testing applies high voltage surges to the motor windings to detect insulation weaknesses. This test can reveal hidden defects that may not be apparent during other tests. Surge testers are used to perform this test. The test voltage should be appropriate for the motor's voltage rating. Vibration analysis measures the vibration levels of the motor. Excessive vibration can indicate mechanical problems such as imbalance, misalignment, or bearing damage. Vibration analyzers are used to perform this test. The measured vibration level should be compared to the manufacturer's specifications. Current measurements measure the current drawn by the motor under various operating conditions. Excessive current draw can indicate overload, shorted windings, or other problems. Ammeters or current clamps are used to perform this test. The measured current value should be compared to the motor's nameplate rating. Temperature measurements measure the temperature of the motor windings and other components. Excessive temperature can indicate overload, poor ventilation, or other problems. Thermometers or thermal imagers are used to perform this test. The measured temperature values should be compared to the manufacturer's specifications. Power quality analysis analyzes the voltage and current waveforms of the power supply to the motor. Power quality problems such as voltage imbalance, harmonics, or transients can damage the motor. Power quality analyzers are used to perform this test. The analysis should identify any power quality problems that may be affecting the motor. Additionally, here are some specific considerations for testing three-phase equipment. Firstly, when testing three-phase motors, it's important to ensure that the voltage and current are balanced across all three phases. Imbalanced voltage or current can lead to motor overheating and reduced efficiency. Secondly, when testing three-phase ballasts and lamps, it's important to ensure that the voltage and current are within the manufacturer's specifications. Overvoltage or overcurrent can damage the ballast or lamp. Thirdly, when testing three-phase equipment, it's important to use appropriate safety precautions to prevent electric shock. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and ensuring that the equipment is properly grounded. It's also crucial to establish and maintain a comprehensive safety program within the electrical testing shop. This program should include regular safety training for employees, proper procedures for handling hazardous materials, and emergency response plans. By following these guidelines and recommendations, electrical testing shops can ensure the safe and reliable operation of three-phase motors and equipment. This contributes to improved workplace safety, reduced equipment downtime, and enhanced overall productivity. Remember that continuous learning and staying updated with the latest industry standards and best practices are essential for maintaining a successful and safe electrical testing shop. Investing in training and development for employees can help them stay abreast of new technologies and techniques, ensuring that the shop remains at the forefront of the industry.